In this presentation we are going to report some results of our project on monitoring of lower Volga arid wetlands, conducted by the State Oceanographic Institute of Russia, with the participation of the Moscow State University. This study focuses on 15 test sites, located inside and around of a floodplain, between Volga and Aktuba rivers, northwest of the Caspian Sea. Most of them are arid or semi-arid wetlands, having homogeneous, but different vegetation types. The fraction of absorbed photosynthetically active radiation, also known as FAPAR, is recognized as one of the most important indicators of vegetation activity. Its value emerges from 3 bands of satellite imagery, namely red and near-infrared, with blue one used for atmospheric correction. Even though FAPAR time series are publicly available, due to the nature of remotely sensed data, they suffer from several issues. They are not continuous in time, they can contain gaps, include outliers, and even big ones, and can be noisy. Thus, comparing time series quantitatively for different years becomes a challenge. Time series can also have important temporal features, like secondary fluctuations, the day of the maximum value, the length of active vegetation period, and others, which are hard to analyze under these conditions. A continuous approximation of FAPAR time series would allow us to get out of the troubles. Our approach bases on the assumption that the vegetation has some normal, year-to-year steady cycle, and nothing happens between growing seasons. If a year is not anomalous, environmental conditions have minor effect on the normal cycle. So, the yearly model FAPAR function is treated as periodic over time. For more reliability, we use data from several years. Taking some extra assumptions into consideration, we construct a harmonic, time-continuous approximation for the normal yearly vegetation activity cycle. The newly derived function gives us more capabilities to quantitatively analyze the dynamics of vegetation activity. The new indicators include maximum FAPAR value and its day of the year, relative amplitude of secondary harmonics, and others. For example, we compute the so-called weighted period of active vegetation as an integral, where days with FAPAR values above the specific threshold are counted as usual. Days with FAPAR values below the other specific margin are not counted at all, and days with intermediate values of FAPAR are appropriately weighted. You can find out more details in our journal manuscript. The next examples show the capabilities of the technique for visualization